Now let's continue with class number 10 for the IB Mathematics standard level course. It's circular functions. For circular functions, we need to know the behavior of the sine, cosine and tan function. We need to know the special triangles, we need to know quadrants, we need to know identities, and we need to know how to solve questions. So we can start with the unit circle. What does the unit circle say? Is a circle that has the origin at 0 and 0 and a radius of, this circle has a radius of 1. So if we want to draw our circle is like, so we can do like this, and we have to move it. We can move it, just move it at the center, yeah. So the radius of the circle, the radius is equal to 1. And we have, the most important thing is quadrants. This is the first quadrant, as you can see, is from 0 to 90. This is the second quadrant, 90 to 180. The third quadrant is from 180 to 270 degrees, and the fourth quadrant is from 270 degrees to 360 degrees. And since we know that in rad the pi represents 180 degrees, just let's see our quadrants and what we call the angle in each quadrant. The first quadrant is from 0 to 90 degrees, which is from 0 to pi over 2 in rad, and we call the angle in the first quadrant, if from 0 to 90 degrees, an acute angle. The second quadrant is from 90 to 180 degrees, which is from pi over 2 to pi, and we call this angle in the second quadrant, we call it obtuse angle. The third quadrant is from 180 to 270 degrees, which is from pi to 3 pi over 2. And the fourth quadrant is from 270 degrees to 360 degrees, and is from 3 pi in rad, 3 pi over 2 to 2 pi. We call an angle which is from 180 to 360, either in the third or the fourth, we call it a reflex angle. These are my quadrants. Now, let's say I'm having my angle in the first quadrant to be theta. To find what the value of this angle in the second quadrant, I have to do 180 minus theta degrees. This is in the second quadrant. In the third quadrant, it's 180 plus theta. For the fourth quadrant, it's 360 minus theta. This is how I can find my angle. This is theta in the first quadrant. In the second, it's 180 minus theta. In the third, it's 180 plus theta. And in the fourth is 360 degrees minus theta, or what's equivalent to these values in radian meters. Now let's see some special triangles and the values of angles. Let's start with the 30-60 triangle. Let's draw it. This is a right angle triangle. Okay, I have it like this. This is so This is 90. This is 60 degrees, and this angle is 30 degrees. The side opposite to 30 degrees is always a 1. The side opposite to 60 degrees is square root of 3. And the hypotenuse is 1 squared plus the square root of 3 squared under the square root, giving me a 2. So here now, this is my first special triangle. My second special triangle is the 45-45 triangle. Let's draw this triangle. This angle is 90, this side is 45, this side is 45. Now, we take the opposite side of 45 to be 1, and this side is also 1. So now, to know the hypotenuse, we have 1 square plus 1 square under the square root, so it's a square root of 2. So now, if you need to find sine of 60, sine the angle 60, is equal to opposite over the hypotenuse, which is square root of 3 over 2. If we want to find, let's say, cosine 30, is equal the adjacent over the hypotenuse, which is square root of 3 over 2. 60, the angle 60 is the same as pi over 3. And the angle 30 is pi over 6. Let's check here. If I want to find, let's say, tan of 45. Tan of 45 is opposite over adjacent, which is 1 over 1, which is equal to 1. Let's find sine of 45. Is equal to opposite of the hypotenuse, which is 1 over square root of 2. If we want to find the cosine of 45, is equal also to adjacent over hypotenuse, which is equal to 1 over the square root of 2. As we can realize that sine of 60 here is equal to cosine of 30, and the sine of angle 45 is equal to cosine angle 45. So we can conclude that sine theta is equal to cosine 90 minus theta. This is an important identity. This is an important identity that we have to know. We know that we have that sine theta is equal to cosine 90 minus theta. Now, let's check the behavior of functions and the sketch of functions for the sine theta, cosine theta, and the tan theta. Let's start with sine theta. We want to sketch it from minus 360 degrees theta to 360, which is the same as from minus 2 pi theta to 2 pi. Let's draw our axis first. It's important to know that the maximum value for sine theta is 1. and the minimum value is -1. So the minimum is -1 and the max for this function is +1. That's very important to know. So start drawing. This is my 90 degrees. This is 180. This is 270. And this is 360. Here I'm having a 90 is a minus 90 minus 180 minus 270 and minus 360. If we wanted to sketch, we start sine of 0 is 0 and we go to the 90 to 180 and here I'm having 270, 360, so we sketch it like this. And in negative theta, we have it this way. Let's check our quadrants. We've said that from 0 to 90 it's the first quadrant. This is the second quadrant. And 180 to 70 is the third quadrant. And from 270 to 360 is the fourth quadrant. We can know that now sine theta is positive in the first and the second quadrant and is negative, this is for positive theta, and negative in the third and the fourth quadrant. It's really important to know in which quadrant sine theta is positive and negative, the minimum and the maximum of sine theta. These characteristics are really important. These characteristics are really important. But let's check for negative theta here. In the negative theta, sine becomes negative in the first and the second quadrants and positive in the third and fourth quadrants. Due to this, we can conclude that sine theta we are talking about the negative part. So we can conclude that sine negative theta is equal to negative sine theta. Because in the negative part, it's reflected. The function is changed. It becomes positive in the third and fourth quadrant and negative in the first and second. So we can conclude that sine negative theta is equal to negative sine theta. That's what we have to know for the sine function. And this is really important to know. Let's now go to the cosine function. I want cosine theta. Cosine theta, and I want to draw it also from negative 360 theta to 360 degrees. Let's draw our axis. Now, for the cosine, we have a positive 1 to be the maximum value, and the negative 1 is the minimum value. Let's extend this line. is the same as this sine function but shifted not by 90 degrees. This is 360, and let's label the negative side. This is negative 180, negative 270, and negative 360. This is like this, and we can sketch it now. This is my cosine function. And in the negative theta, this is my cosine function as well. Okay. Now, the first thing which is important to know that the minimum value for the cosine theta is -1, and the maximum value is equal to +1. Let's check for which quadrant the cosine is positive and which quadrant are negative. Let's see, this is my first quadrant. As you can see here, it is positive because it's above the x-axis. And in the fourth quadrant, it's positive. The cosine is negative in the second and the third quadrant. So now, cosine theta is positive in the first and fourth quadrant and is negative in the second and third quadrant. Let's check for negative theta. If you can see, for negative theta, there is no change for the cosine. So, still positive in the first quadrant and the fourth quadrant, and it's negative in the second and third. So by this we can conclude that cosine negative theta is the same as cosine theta. These are really important, and we have to know these characteristics really well. This is for sine and cosine. Now we can go to sketch the tan function. Let's sketch the third one. Let's sketch tan theta. We're gonna sketch it from -360 degrees to 360. Just draw another line. Now this is 90, 180, 270, 360, -90, -180, -270, and this is -360. For the tan, we have asymptotes, which means that tan of 90 has no value. On the GDC or the calculator, it gives me an error. We can check it now. Let's check the tan of 90. We have our GDC here on. The first thing to check, if I want 90 then in degrees, I need to check the mode if the GDC in degrees. I go to mode. This is the third choice. My GDC in radians. I have to change it to degrees. So I go down, I go to degrees and simply press enter. Then I second quit. I want tan of 90. It gets me an error. This is an error. See? So we don't have a tan of 90 because we have an asymptote here. If we want to sketch our function, let's sketch it in green. We have it this function this way. This way as well. We know that tan 180 is a 0. And we continue this way. And this is like this. So, let's start with, if you can see the function from up, it goes to positive infinity, and downwards go to negative infinity. So, the minimum value that I have for the tan function is negative infinity. The maximum value for this function is a positive infinity. Let's check the quadrants. If you can see, the tan is positive in the first and the third quadrant and negative in the second and the fourth quadrant. So tan theta is positive in the first and the third quadrants and negative in the second and fourth quadrant. Now, let's check the negative theta. For the negative theta, the function becomes positive in the second and the fourth quadrant, and it becomes negative in the first and the third quadrant. So it flips. It's like the sine function. So we can conclude here that tan negative theta is equals to negative tan theta. Tan negative theta is equal to negative tan theta. This is for the tan function. This is for the tan function. Now, after we discussed the behavior of these circular functions, now we can go to some identities. Our most important identity that we need to know is that sine squared theta plus cosine squared theta is equal to 1. This is our first identity, and it's the most important identity. This is our most important identity that we have to know. Another identities we have the double angle identities. We have sine 2 theta is equal to 2 sine theta cosine theta. This is our second identity. And the third one, we have the double identity also for the cosine. We have cosine 2 theta is equal to cosine squared theta minus sine squared theta. And this comes in many forms. Why? Because cosine squared theta is equal to 1 minus sine squared theta. So we have it like this. We can write it like this. It's 1 minus sine squared theta minus the sine squared theta. So this is equal to 1 minus 2 sine squared theta. Or we can change the sine squared theta. So this is equal to cosine squared theta minus the sine squared theta also is 1 minus cosine squared theta. So if I expand the bracket, it gives me 2 cosine squared theta minus 1. These are the identities that we have to know. Now we can go to solve a question from the question bank. Let's start with part A. Show that 4 minus cosine 2 theta plus 5 sine theta is equal to 2 sine squared theta plus 5 sine theta plus 3. So I can take the left-hand side of the equation and make it equal to the right-hand side. Let's take the left-hand side. We have 4 minus cosine 2 theta plus 5 sine theta. If I get back to my identities, I want to change the cosine 2 theta in here. If I get back to my identities, I find that cosine 2 theta is equal to 1 minus 2 sine squared theta. So it's 4 minus the 1 minus 2 sine squared theta plus 5 sine theta. So it becomes 4 minus 1 plus 2 sine squared theta plus 5 sine theta, which is equal to, this value is equal to 4 minus 1 is 3. I have 5 sine theta, which is 2 sine squared theta plus 5 sine theta plus 3. So I made the left-hand side of the equation equal to the right-hand side. This is exactly as the right-hand side. Now let's go to part B of the question. Part B, the question begins with the word hence. It begins with the word hence. Hence, it means I need to use what I did or my answer in part A. Hence, it means using part A, you can solve this question. Since I do know that this value is equal to what I find in part A, I can simply change it. So what is in part A is I'm having 2 sine squared theta plus 5 sine theta plus 3. So it's 2 sine squared theta plus 5 sine theta plus 3 is equal to 0. Now I need to solve this equation. To solve this equation, simply I treat sine squared theta as sine theta as x. So it becomes like this is a quadratic equation. It's like I'm having 2x squared plus 5x plus 3 is equal to 0. So I will factorize as I'm having simply a quadratic trinomial. So I'll factorize, I'll have 2 sine theta times sine theta, because 2 sine theta times sine theta gives me 2 sine squared is equal to 0. I put is plus 3, I put the plus 3 here and plus 1 here, because 2 sine it gives, yeah, it's a good factorization. Now I'm having two equations. This is the first one and this is the second one. So let's split them up. The first one I'm having sine theta is equal to minus 3 over 2. And the second one I'm having sine theta is equal to negative 1. Okay, let's solve the first one and we go to second one. But I need my answer in radians. Why in radians? Because this range is in rad, is from 0 to 2 pi, is in rad. I need my answer in rad. So the first thing to do the question is I have to neglect the sign. I need to find theta in the first quadrant first. Always I need to find theta in the first quadrant. Now, I'm having sine theta is equal to negative 3 over 2. which is less than -1. Which is less than -1. And we've said before from the sine function that the minimum is -1. I'm having here sine theta equal to -3/2. -3/2 is out of the range for the sine, so I will have no value. If I can't check my GDC, I want to go to find shift sine inverse on. This is on. Second, I go sine inverse of -3/2. I'll have an error. I won't get a value. This is an error because I don't have a sign of less than -1. So simply here I have no solution. Let's go to my second equation. I have sine theta is equal to -1. I want to check where sine is equal to -1. -1 is here for the sine. So sine the 270 is equal to -1. Sine the 270 is equal to -1. So my angle is 270, but I need my answer in radians. So to change it to radians, simply I multiply times pi over 180. So theta is equal 270 times pi over 180. 270 becomes 3, and this is a 2. So my answer, theta is equal to 3 pi over 2. And in this case, I'm having a one solution only. There are many questions and in the question bank, previous exams, and in your textbook. So it's really essential to practice really well for trigonometry and for circular functions.